My name is Stefan Seiter, and I'm teaching in the Crop and Soil Science department. I serve as both a lecturer, but also as an advisor to the students. And part of the reason why I'm talking to you about agroforestry systems is that I did a bunch of research on this topic and specifically on alley cropping. This was actually part of my dissertation, part of my PhD dissertation when I was working on agroforestry systems. Let's start by just talking very broadly about agroforestry, and then we get more into the details of alley cropping. The word agroforestry kind of tells you what it is. So basically a combination of traditional agriculture with forestry, and that's where the word comes from. It's not just kind of throwing things together, but it's really intentionally working on both and combining them both to create economic benefit, to create an environmental benefit, and hopefully also a social benefit. So it's combining these, the agricultural part and the forestry part into one intentional design system. So the agricultural knowledge and the selection of the species and the management of the trees, all of that is sort of needed to optimize production in the system and to minimize any competitive effects. But broadly, agroforestry systems are classified based on what kind of species are involved in it. So in the first type, it's called the agri-silviculture systems. You have trees and crops combined. And then in the second type, you have silvopastoral systems, which basically connects the trees and livestock. So the trees are always in there. And then the agro-silvopastoral system, where you have all three. You have trees and crops and livestock, all of that combined. On the pictures here, you see kind of a traditional alley cropping system on the left. In the middle, you see more of a forest farming type system, also called multi-story cropping sometimes. And then over here, you have sort of a silvopastoral system where you pasture. Actually, in this case, you also have the animals. So it would be a full-on agro-silvopastoral system here. This shows also a slide of that. And that's really the most complex type because there is a lot going on, obviously, in that. There's a lot of interactions between the animals and the crops and the crops and the trees and the trees and the animals. So there's a lot to consider in that system. And from what I've seen in my short visit to Bhutan, this is actually quite applicable to your situation in your country. I've seen many of these systems. They were not necessarily intentional. If you would make them more intentional, I think there would be a big potential. And certainly when you are finished with your studies at CNR and you go out and have a job, there is much for you to optimize these systems since they're already out there. So why agroforestry? The point is that we're trying to optimize a system that is somehow advantageous over just the agricultural and just the forest production by having more economic benefits and enhanced outcomes and services. And I'll just put up a full list, and then we actually go through those benefits more one by one later on. But you produce multiple products because you have tree products and the crop products and animal products. There is a chance that you can optimize that and actually then increase crop yield and livestock production for a particular area. You have spreading of the risk because you have multiple products that are coming on at different times. You have the potential for maybe creating value-added products, especially on the forest side, because you can do many different things with the timber that you harvest there, but also on the crop side to a certain degree. And then it does increase property value as well. Another general point, how is it connected to sustainability? And there's really a number of ways kind of how agroforestry contributes to sustainability in the bigger picture. Certainly there are economic benefits. We'll talk about those and the products that you produce there. But there's also the environmental benefits. And again, we'll talk about carbon sequestration and how it may contribute to also cleaner water and air. and then a number of social benefits that you would have over kind of the monocropping type system of crop production or only tree production. I'd like to go into a little bit about what generally we have on benefits when we put multiple species together. You already talked about much of that, but I want to set the stage a little bit so then it's easier to understand the alley cropping. With any cropping system that puts more than one species into a field, your hope is that there is some advantages to that in terms of overall productivity. You're trying to optimize the resources that you have, and we'll look at that. You're trying to potentially get some pest management benefits out of that, reducing pest management, reducing pest damage. And then you're trying to provide greater stability in terms of cash flow, in terms of human nutrition, in terms of overall sustainability. And so when we look at some of these a little bit more, how do you increase productivity compared to monocrops? Because, if you look around the world, most crops are produced in monocrops. So gigantic fields, at least in those countries where you have those fields, very big fields, all a single crop. And there are good reasons for that, but especially on smaller acreages and where you have more limitations on the land, there is a good reason why you might want to do multiple cropping or multiple crops in one particular field. So just bear with me here, just a simple example, and it's just totally hypothetical. If you have an acre or a certain area and it produces a certain yield, and another second area then produces a second crop, also a certain yield. So your hope is that if you combine that, you will get actually more. And there it depends very much on how you put the crops together, what kind of crops you're putting together. Ideally, you put crops together that have different needs, because then they use resources in a much better way. So, for example, this is just hypothetical, but you might actually reduce the corn yield because corn is quite susceptible to competition. So you might actually only have half of that. But pumpkins or squashes are less susceptible to a lot of the resource competition, and they might produce more. So in the end, you end up with something more, and thereby increasing your overall productivity. Whether or not that makes sense, it depends always on the individual farming system. If this makes a whole lot more work, it might not be worth it. But if it's not making more work and maybe actually reducing work because potentially the pumpkins cover the ground much better, so you don't have to do as much weed management, then actually it would be a nice thing. So when we talk about optimizing resources, that's resources meaning land, labor, time, natural resources. And on the natural resource side, we're talking about light and nutrients and water that we're trying to optimize in the system that has multiple crops in the same field. And our goal is to minimize the competition for those resources, but at the same time, maximize any kind of sharing that's going on. So sometimes some crops like shading, for example, and they grow better under a little bit of shade. Some crops benefit maybe from if one crop has nitrogen fixing ability and then they give up some nitrogen to the crop next to it. There are different ways of how you can manage or how you can design a system that does that. But basically, we're always trying to look at these intercrops when you grow multiple things together and see what resources are not fully used and can we change which crops we're using so they're not using the same resource, but they're different in space and in the time dimension. And so they share different resource pools. So that's our goal here. So this is an example of a bok choy field, but above it, you can see they grow kiwis. So this is a great example of resource sharing. So space is used very efficiently because the crops grow on the same area, but on different levels. So it uses the light very efficiently, especially if the bok choy has most of its growth time during the time when the kiwi plants have not a lot of leaves on them. So this is a nice example of how you can use different resource pools. Very likely the farmer also makes good use of the soil resources because the roots of the woody plants here extract the nutrients from deeper down and also the water. In addition, labor is used very efficiently because the harvest time of the two crops is different. Here's an example of an intercrop in Oregon. And in a way, that's not really in the traditional sense of an intercrop because the cereal that's grown here in the middle is not really used. It's simply there to protect those young melon seedlings. This is in an area where there's a lot of wind and the melon seedlings have a hard time getting established. And so they grow this cereal, they kill it, in this case chemically, looks like, and then in this time, the melon seedlings can establish themselves, and then this completely dies back, and the melons just grow over that. So it's sort of facilitating, this crop facilitates the growth of the other crop. More traditionally, this would be how hazelnuts are grown in Oregon, in pretty wide spacing because they get very large. But before they close canopy, the grower can make use in those first few years when the trees are not yet bearing nuts. In that time, and when there's a lot of space and there's a lot of light available, they can grow an intercrop. And then later they will stop doing that. But for some years, they can grow beans or other plants in between. Good example of how resources are shared. And as I said, in most agroforestry and also intercropping systems, you also have a good potential for having reduced pest damage, especially insect pests, because you can create different habitat, especially if you have a multi-story, trees available. So you have a lot of habitat complexity in the trees, and that provides a lot of habitat for beneficial insects that could potentially then feed on insect pests that are in the alleys. In addition, and I'm just using an example not out of agroforestry, but you have a good potential for having one of the species, either the trees or something else that grows in between, that can attract natural enemies and other crops that may be pushing out, so that maybe have volatile chemicals that the insects don't like, and so it pushes them away actually out of the crop. So you have that potential in agroforestry for having more habitat, but also for creating attractive plants to enemies and very non-attractive plants to pests. Now I want to get into alley cropping. So first I'll define what it is again, although it's pretty obvious what it is, looking at the different benefits specifically of alley cropping and not agroforestry in general. And then think about what are basic design considerations. What do you need to think about when you put together an alley cropping system? And then also look at what would be potential crops that are well suited to alley crops, because some are and other crops might not be. So you need to think about it when you design a system like that, or when the farmer puts a system like that together. So there are many different definitions used for alley cropping, but essentially it is growing trees or shrubs, so any woody plants in either one row or multiple rows, and have then agronomic or horticultural or forage crops in between these alleys of these rows of woody plants. And you can see it can be more narrow rows like here. And this is poplar trees and wheat grown in between. And it could be very wide rows. And in this case, they grow nut trees here, and they have a very wide swath here, a very wide alley where they basically grow hay, which is then later used for plants. But it's been around for a long time. It may not have been called that way, but you certainly can go back in European and American history, and you can see alley cropping systems from 300 years ago. And probably Native Americans have done that even much earlier than that. So many different possibilities, and it's an old system. It's just more now it's defined, now it's called something. Probably it wasn't, it was just done in the past. So we can draw on all of the experience from our ancestors and from people who have done this for a long time. So I'm going to go through some of these benefits here, and I just put the whole list up. And not all of them, what you see here, do apply to every alley cropping system, but these are some of the major ones, some of the major benefits, and I'm going to go through most of them. So obviously it does produce multiple products, and you always select the tree or the shrubby component, the woody component, to also yield you something. Sometimes shrubs are simply used to be of a environmental benefit, so maybe having habitat for beneficial insects. If you think about the hedgerows that you see in kind of a traditional English landscape, they had their purpose too, but they didn't serve necessarily as yielding a particular product that you eat or that you harvest, but simply it was there for wind protection and was there for housing beneficial insects and such. So it's more of a service function. But generally nowadays, you'd always select a woody species that also yields something, either in the long term, like wood or timber, or in the short term, like nuts or fruit. This is an example from the United States. A lot of my examples are from the temperate region and not necessarily from Bhutan or the more subtropical regions. But I think you can make the connection of what would be suitable for your climate. In many cases, there are crops that actually benefit, especially when they're grown. In this case, this is grown in the south of the United States, where it's quite hot. Grass that's grown in here is suffering from heat stress. So actually, the trees in this case, they provide some protection from that heat stress and reduces evapotranspiration by up to 30%. And in the end, this actually saves water and also produces a better hay. And then if you can think of maybe vegetables or other crops that might suffer from wind or from sand particles that are blowing into the crops, if you think about the shrub line here, could protect those plants from reduced in quality. So if you have fruits or vegetables, they might fall into that category of plants that need to be protected from physical damage. Another benefit is that we're using a layered system that uses horizontal and vertical space in different ways, and you can integrate a variety of different crops, and that increases crop diversity and improves kind of economic returns. And especially if you think about annual crops, you can use that to constantly sell annual crops. That's good for your cash flow. But then the wood that you grow in the rows, there would be a long-term investment. So there might be walnut trees and you harvest them every 30, 40 years. So that's a long-term investment that you do maybe for your children, maybe for whatever. It's a short-term versus a long-term investment. Also, in that alleyway, you can have more than one crop. You can have a forage crop and a fruit crop. There are different possibilities on what you can grow, but overall, there's a clear advantage to increase crop diversity, which reduces automatically the economic risk. If one crop fails, the other one might do well. Whenever you include any kind of woody plant, you always increase carbon storage in the soil, because you create a large and deep root system, and automatically in this tissue, you have carbon stored. It's mostly carbon that's contained in these roots. And the same is true for the trunk of the shrub or the tree. So you have roots and crop residue, and all of that leaves basically have stored carbon. So whenever you do that, compared to an annual crop, you store a lot more carbon long term. And if you sequester all that carbon in the biomass of the trees, that obviously then pulls carbon dioxide out of the atmosphere and enhances our goals to reduce overall carbon. I think probably the most researched and topic in agroforestry is the whole issue of nutrient cycling. It makes a lot of sense because it's pretty obvious what's going on. So basically, when we think about a forest ecosystem where you have fairly close canopies, you have litter that falls down, microorganisms decompose that litter, and those nutrients get picked back up into the tree, and so the circle continues and continues. And there's very little loss from the system, especially in a closed forest ecosystem. In agriculture, we obviously have kind of the opposite. We constantly export a lot of nutrients by harvesting, but then also a lot of nutrients are lost with erosion, with leaching, because we're constantly working the ground. So a very heavy loss out of the system. And so the idea in agroforestry system is basically bring those benefits out of the forest ecosystem into an agricultural system and sort of have the best of both worlds, where you have the nutrients being conserved, being recycled, and then having a more closed system. It won't be perfect like a forest ecosystem, but at least we can use a lot of the principles here and hopefully recycle as many nutrients as possible. You have these deeper roots, and basically when you have these deeper roots, they can pick up any nutrients that were applied to the crops that would otherwise get lost. Because especially when you think about nitrates, a lot of farmers are using nitrogen fertilizers that contain a lot of nitrates. Nitrates are not held very well in the soil. So if the crop is not ready to pick up all the nitrates that are applied, then very quickly they leach out of the soil. In almost every agricultural system in the world where there's a lot of nitrogen applied, you'll have very heavy environmental damage because of that leaching. But if you have a root system that can pick up some of that and convert it back into biomass, that obviously is a positive thing. So the nutrients get recycled, and then they again can feed the crops back with the leaf fall, or like I will show in a little bit from my own research, you can use the tree leaves and the branches as a green manure. So you can do that as well. At the same time, in most agroforestry systems, especially in the tropics and subtropical regions, they use mostly nitrogen-fixing trees. So these nitrogen-fixing trees, they release a lot of their nitrogen back into the soil. The nodules die, the small roots die, the root hairs die, and it's a very nitrogen-rich material, and that can be recycled back then and used by the crop if it's managed correctly. Or it might be recycled by the tree itself, depending on the management. As I said, when you prune the tree, or what I'm going to show in a little while from my own research, we coppice the tree, meaning we cut it, we only let it grow basically as a stem in the very bottom of, and then maybe a foot above the ground or even closer to the ground, everything will be cut off, and that can be used as a green manure. Or in a lot of places where you have animals also nearby, you can use that nitrogen-rich material also as a fodder. So here's an example from a tropical regions where they grow corn or maize, and then Lucina, which is a nitrogen-fixing tree. And that's a very common alley cropping systems in tropical and subtropical regions. I know it's used a lot in Thailand and the Philippines. And these trees or these shrubs are cut back pretty dramatically when the corn starts to grow higher. And then this material in most subsistence farming systems, this is used as a tree fodder. Here's another system, also tropical, subtropical region, because you can see cassava here, and then another crop in here in between those trees. It looks like they're not cutting them back as dramatically. So maybe the cassava can handle a little bit more shade than the corn can. Corn is very sensitive to light competition. So I would not grow corn or maize in a shaded system. Many years back, I published this study where I looked at an alley cropping system in the temperate climate. So in Oregon, I wanted to see where does that nitrogen that's in the tree and that's in the prunings, where does it actually go in this alley cropping system? Nitrogen occurs naturally with different isotopes. It's mostly N14, and it has to do with the weight of the atom and with the number of neutrons in the atom. But in any case, it mostly there's N14, but it has a little bit of N15, and it doesn't damage the plant if you put more N15 into the plant. So we did that, and this is not from my plot, but it gives you a sense of what we did. We injected the tree with this N15, basically replacing the N14 with N15, and had then a completely different ratio of N14 to N15 in the plant, in those trees. And then we could follow wherever this different ratio between those isotopes occurs again. We knew it had to come from that tree. It couldn't come from anywhere else because nothing else in the environment has that new ratio of these two different isotopes. But in any case, I had many of these plots on the research farm, and this line here are my trees. These thin lines are my corn rows. And so I had multiple corn rows in the alley of these trees. And then I injected some of these trees with this solution, with this new nitrogen, and replaced the old nitrogen. And then I took soil samples in different ways. So then I was able to follow that nitrogen on where it goes after I prune these trees and put the prunings into the corn, because I wanted to see whether this is an effective way of fertilizing the corn, basically, and that maybe I could reduce my amount of synthetic fertilizer. So I was following that nitrogen around, and so basically here it's just percentage-wise. So there is a tree pool of nitrogen, a soil pool of nitrogen, and the corn pool of nitrogen. So everything is in the trees at this point of this new nitrogen plant tissue. But then when I put the prunings onto the soil, it gets picked up by the corn plants, and then it lands in the corn plants. So I could measure that by doing thousands of soil samples. And so I could follow that along and basically see, okay, where does that nitrogen that I put in initially go? When it goes through the soil, then it gets mineralized and the nitrogen goes into the corn plants, or it goes back into the trees, which is also possible, or it stays in the soil. And so I did that for 2 years, and basically could then kind of account for where all the nitrogen goes. So very interesting study to really see what happens to the nitrogen that is in those trees, instead of always just saying, well, it happens. I don't know how much, I don't know how, but it happens. So this is really a way of quantifying what nitrogen goes where and how much is staying in the soil and such. This gets a little bit more complexer, but where it says here row 1, 2, 3, it means row 1 away from the tree, or this one, or this one. So this is row 1, this is row 1, and this is row 1. So 1 away from the tree. Row 2 is further away, row 3 is yet further away. And I could also look at, if a plot did not receive any prunings, is nitrogen from the roots going all the way over into my corn? And I could see that it does, but only as far as row 2. Row 3 did not get any benefit nitrogen directly from the tree. Where I put prunings on, you can see that there's quite a bit of nitrogen, and this has to do with percentages, so I won't go into detail here, but you can see it's more evenly distributed where I put the prunings onto here, so the nitrogen actually went into the corn. It wasn't enough to feed the corn completely, but I could save about 1/3 of the fertilizer. So that was nice to see. But in tropical system, actually, in what I showed earlier with the Lucina, you can create so much biomass and so much nitrogen that you can feed the entire corn crop. You don't need any fertilizer. In my temperate climate, that wasn't possible because my trees are not growing as fast as the tropical Lucina trees. Alley cropping is used quite a bit on slopes because it has this natural tendency to, when you plant the trees, you will have any runoff or erosion kind of collects where the trees are, and then it creates little terraces. And any tree leaves fall onto the ground, and it reduces erosion in the first place. So it's a really nice place for planting it on a slope, and which would be very, very relevant, obviously, to Bhutan because much of your growing is on slopes. Not only does it help with terracing and erosion control, but any nutrients that are attached to soil particles that are moving, they are more likely to be picked up by the trees, especially if they're planted on a contour on a slope, because it traps the sediments and any attached nutrients and also chemicals. So if there was spray, it could also trap that spray and keep it there. Because of all the root activity in the tree roots, there is more infiltration. It will infiltrate there and it will not affect the cropping area. And then it has wonderful benefits for wildlife because you have that multi-story complex habitat of the trees, and that provides all kinds of food and cover for many birds and insects and such with this vertical habitat structure. And obviously, if you have anything blooming, then you have potentially, so trees can bloom, shrubs can bloom, you have nesting habitat, and you have pollinators that have a nice habitat there. In addition, it provides a corridor for larger animals, especially for birds, where it can connect maybe a forest with another forest if the wildlife species have that way of traveling from one to another and using these tree rows or shrub rows for that. It's not all rosy and all good. There are many things that you need to consider. Everything sounds wonderful about alley cropping, but it is actually quite complicated. You can make a lot of mistakes. So I want to point out a few of those. It involves a lot of management. In the example I used, I had to be very careful when I cut the trees. So I had to cut it in a time when I already had produced a lot of biomass, but I had to cut it before it provided too much shade for the corn that was growing in between. So the timing was very, very critical. If I would have waited 2 weeks too long, then there would have been a lot of damage due to shading or maybe competition for nutrients or such. And farmers often don't have that luxury of, like a researcher, to go in at exactly the right time. So it's very intensive management. Also, if your goal is to produce as much rice as possible, having trees in the field is not a good thing because it removes actually some land from your production of the rice. So you need to consider that. And then if you do any kind of application, whether that's manure, whether that's fertilizer, whether that's pesticides, it gets quite complicated because you might damage one with something that you don't want to have damaged, or things are in the way. You cannot use a tractor. And so it's complicated to do that. And then if you have kind of a woody plant, you need to think about, well, how can you market that woody plant? If you might be used to market to sell the annual crop, but you might not have a market yet established for those woody products. So there's a lot of things you need to think about when you start creating an alley cropping system, even though it has all these wonderful advantages. And so one of the main design consideration is, what are the light requirements for the crop or the forage that you grow in that alleyway? If they're very susceptible to light competition, you need to be very, very careful in how you manage the woody component and what kind of species you are using. Same is true for root competition. If you have woody plant that completely takes up a lot of root space, and grows wildly into the alley, that is not a good thing. You can't use that in an annual crop. And then if you are in a system where they use a lot of equipment, you have to adapt your equipment, and you have to even think about what spacing you use, because that's what I did in my system. I always thought about how wide is my tractor? Can I get the tractor through there? And how wide is my tillage equipment? Can I get that through there? And how wide is my planting equipment for the corn? You have to be then mindful of all of that. As part of my research, I explored that also. The graphics are kind of old here, so I apologize for that. But I basically used 3 different alley cropping systems. One that was kind of extreme, where I planted a row of crop, a row of trees, a row of crop, a row of trees, a row of crop, row of trees, and so on. So it just alternated between crop, which is a C, and the tree, which is a T. And then more of a traditional system where I have a double row of trees, and then I have 4 rows before the next row of trees. But that took away some corn plants. And so then I said, well, maybe I can squish the corn plants closer together, those corn rows. And then I compared it to widely spaced and narrowly spaced corn. What I had in the end was a system where 50% of the space was, not 50% of the plants, but 50% of the space was taken up by the trees in one system. And in this system, only 14% was taken up by the trees. And so then I compared the yield in these systems. It was nice to see that, yeah, in this system, I had some yield reduction where I used more space for the trees and not as much. But when I squished them together, I could actually get a pretty almost identical yield to the monocrop. And I'll show you why. But basically here you can see I had basically roughly 100% of the yield in that very narrowly spaced system, but quite a reduced yield in where I did trees, crop, trees, crop, trees, crop, because there was just too much competition going on between those. And I tried different temperate climate trees, but the pattern basically continued. It wasn't exactly the same, but the pattern was similar to that. And what was really interesting and totally unexpected is when you prune the trees at the right time, there's actually more light for the corn row right next to the trees than there is light for the corn rows that are more inside the corn alley, meaning that the corn row right next to the tree could capture more sunlight and therefore grow higher than the corn rows that were in the middle of the alley. And that's why I could then compensate for some of the losses with the space. So that was completely unexpected, but it also depended completely on that I was perfect on when I'm pruning the trees all the way down to just like a foot high or lower. So as soon as the corn was about knee high, I would do this and then distribute the prunings and everything onto the cornfield. And that allowed actually then the corn row, and maybe it got also from the other research I just showed, the corn row right next to the trees also received the most benefit in terms of nitrogen from these nitrogen fixing trees underground because of the extra nitrogen benefit from underground sloughing off of the root material. And I showed that in my N15 study. But I think the biggest effect was from the additional light that came in here to these compared to the next row and the next row down in the alley. So that was a kind of unexpected result. When we look at what kind of trees or shrubs should we use, ideally it's something that's marketable, so something you can actually sell. And that could be a wood, but it could also be a medicinal plant or a decorative plant, something that you can market. So ideally you have a yield that's an annual yield, and maybe you get 2 annual yields. But if you don't have that, let's say from a shrub, but it's like a commercial wood, then that would be the longer term. So you need to think about what's a wood that brings you most money or nuts or fruit. You need to think about how much shade you create and whether that's good. Like I showed earlier with the hay growing in the southern United States, or whether that's bad, which is the case like for corn or other plants. You don't want to have roots on the soil surface. Further down, that's okay, but nothing on the soil surface. And both the trees and the shrubs really need to be adapted to that kind of a site and environment and soil. And then also anything that falls off of the shrub should not interfere with the crop. So for example, that's a problem in black walnut. Black walnut is allelopathic and has chemicals in its leaves that inhibit the growth of many plants and also of vegetables, for example. So walnut trees would probably not be good interplanting that with a vegetable. You could interplant it with a hay or so. It doesn't affect the grasses, but a vegetable, it would affect it quite dramatically. So you need to think about that, how that complements the alley crop. In the temperate regions, yes, we use walnut because the wood is worth a lot of money, but then you have to be very careful what you grow in between. Pecan nuts, chestnuts, I use pine also and poplar for the wood. Poplar because it's super fast growing. But in tropical regions, you have a lot of, oftentimes in alley cropping, you have coffee, you have coconut, you have lucina because it's nitrogen fixing, eucalyptus, papaya. So all of those are potential tree species. But you have to be very careful in how much shade is produced, how much root is produced. And so you have to kind of think about that in advance. Is there something compatible between what I grow in the alley and what I grow as my tree crop? So you need to think about that compatibility. And willow, for example, low shade, low root competition, and it provides some early season pollen. So that's kind of nice. But it's not very valuable, the willow. And so other things are much more valuable, but they might have a lot of shade, then that can be problematic. So like I said, it doesn't have to be trees. It can be shrubs. In the United States, they often use hazelnuts, or they use decorative things like dogwood or willow, or they use different kinds of fruit that can be harvested. In the tropical region, you have anon or sugar apple, which is kind of a pulpy tropical fruit. Or pomegranate you could use. Saskatoon is something that grows in the far north, more in Canada and northern United States. So different possibilities there to be used. And in the alleyways, like I said, you can grow any kind of row crops if it's compatible with the trees. You can grow all kinds of forage crops. So on hay, anything that animals can eat, or then specialty crops, but also flowers or medicinals. And lately, I've seen more and more biomass crops as well. So basically energy feedstock crops. And sometimes it's actually where they grow large trees for wood and then shrubby, which is not really alley cropping in a traditional sense in agroforestry, because it's almost all forestry, but it's sort of in that same configuration where they grow trees for wood and then they grow shrubs like willow as a biomass alley crop, both woody components. So it's not agroforestry in a traditional sense. So one grower I worked with in Oregon here, and that was the start. And now it's 20 years later, it looks very different. But he used these various shrub species here, many of them who also have use, like elderberry and hazelnut and other things. And that was based on how wide his planting machine is. He used then an annual crop here, and he did that twice. Further back, it actually goes toward a river, and there he has shade trees planted, and under the shade trees, he has medicinal plants like golden seal and other things that are used in medicine, and that are actually can only grow in heavy shade. He made use of these agroforestry principles. In summary, alley cropping can be great, in terms of crop production if you use the right combination. It's really a good tool for economic diversification and reducing risk. You have a really good potential for using less pesticides, having lower pest pressure in the first place. You almost always have a much better nutrient utilization, much better recycling, and you have good potential for improved soil and water quality. So I'm going to end it right here.